Hi, everyone. Thank you for joining today's webinar, Introduction to Adreno GPUs, Tools and Support for Middleware Solutions. Today, our speaker is Manish Sherdashwik. Manish leads the Tools and Middleware Technology products as part of Qualcomm's graphics product management team. He actively engages with key technology providers and developers to understand their needs, drive innovation, and enable them on Qualcomm's Snapdragon platform. Before joining Qualcomm, Manish worked in the game industry as a 3D game developer. The slides and recording from this webinar will be available by next week and will be emailed to everyone who registered to attend today. The video will also be available publicly on the Qualcomm Developer Network website. If you have any questions during the webinar, please submit them to us by clicking the red Q&A icon at the bottom of your screen. Or if you are on Twitter, you can send us questions using the hashtag SnapdragonGraphics. And we will have Manish answer all of those questions during the Q&A at the end of the webinar. Manish will answer as many questions as he can after his presentation. So with that, we will go ahead and get started. Manish?
Okay. Hello, everyone. My name is Manish Sherdashwik, and I'm a graphics product manager at Qualcomm. And today I'll be introducing you to the Adreno GPU, tools, and the middleware support for developers just like you. So with that, we'll go to the next slide. Snapdragon, with its integrated Adreno GPU, provides a leading graphics application development platform. And I'm excited to take you guys through some of the key points today about Snapdragon that you may not have known. The first point is basically broad global adoption, which translates into direct market opportunity. The secondly, great performance and leading architecture, which translates into making an awesome gaming platform. We also have optimized support for 3D middleware engines, which makes it easier for you to develop great content. And then we also have comprehensive Adreno tools that make your development time and cost more efficient. So we'll go through all these points one by one through the slide presentation. We also have some demos coming up later in the presentation, so for those who are interested. So with that, let's look at the market adoption of the Snapdragon and Adreno, which can translate to the direct business opportunity for you. So this slide here talks about the volume of Snapdragon. Today, Snapdragon processor powers more mobile devices than any of its competition. These devices basically vary across multiple operating systems. It could be Android, Windows Phone, Windows RT, and they also come in different shapes and sizes. So it could be a smartphone or a tablet or a netbook or even laptops, as we are seeing with the Windows platform. So there are more than 500 devices that have been announced based on Snapdragon, and more than 30 of which are actually tablets. We see a very large market share within Android for Snapdragon today. Last I heard it was more than 60%, and all the Windows Phone are powered by Snapdragon. So it's a great market opportunity right there. That was for Snapdragon. So we'll also look into what is Adreno and what is Adreno GPU. So not sure how many of you know this, but just like our CPUs at Qualcomm, we design and build our own GPUs from the ground up, and basically with the mobile use cases in mind. And the name of the product of our GPU is Adreno. The latest Adreno 320 GPU is part of Snapdragon S4 Pro processor. That is in the recently announced Nexus 4 device from Google. If you've seen it, I guess in the last few days they announced it. This presentation will be more focused on Adreno 300 series GPUs and how you can make use of it. Also, a quick fact about Adreno GPUs that you may not know is that we had acquired ATI or AMD's handheld unit about 4 years ago. So we have all the talent and expertise in-house, and we design our own GPUs with their expertise. In fact, one of the core architecture of our Adreno GPU is derived from Xbox 360 Xenos GPU, if you guys hadn't known that. Let's look at the next slide. This slide talks about the overall market share of the GPU, mobile GPUs itself. So another fact that you might surprised by is the Adreno GPUs market share in here. So as you can see, Qualcomm shipped more mobile GPUs than any other mobile silicon provider, which almost accounts for a third of the total mobile GPU shipments. So it's a pretty large volume when you look at this pie chart. And most of the mobile devices that are considered here include smartphones, tablets, and even laptops. So that does include the PC category as well. So you see, we're not just a processor company that provides the GPU, but we are the mobile GPU provider when it comes to enabling your applications for mobile. And of course, we don't want to just bombard you with the marketing facts. So here's how you can actually take advantage of this market opportunity. We help develop, showcase, and even launch great applications that showcase our technology for Snapdragon. So if you want to launch your application with us, please sign up for our Snapdragon developer program, and we would be more than happy to help you. So now that you know the business opportunity that Qualcomm can provide, let's look at some of the technical details here. Snapdragon and Adreno together provide an excellent performance and architecture. Basically, this directly translates into better experience for your applications right out of the box, and leaves you more room to squeeze in even more effects when you need those. So let's look at how. This pie chart or this bar graph actually shows the exponential growth of Adreno GPUs over time. So you can see Adreno GPUs have evolved drastically in the last few generations. Here's just an example of how much. So if you look at on the left side, there's Adreno 200 GPU, and that is what was in the Nexus 1 device from Google, while Adreno 320, which is on the far right, is included in the Nexus 4 device that was just announced. So you can see the Adreno 320 has almost 22 times graphics performance of Adreno 200, so which is a drastic increase. And that was, I guess, a little more than 2 years ago that 200 was launched. So Adreno 320, as of the bloggers and the reviews that are coming out, Adreno GPU is the fastest GPU in market today. If you can go to AnandTech and look at the reviews of all the benchmarks, and that confirm that. We also have come a long way in such a short time, and we continue to have this growth exponentially. So you'll see even aggressive roadmap from us going onwards. Okay, next slide. So a lot of times, there is a confusion between number of CPU cores and what it translates to in the graphics performance. So here's a quick chart of comparison, but you can see Snapdragon dual-core processors are often better than competitors' quad-core processors. And in fact, Snapdragon quad-core processor beats everyone by significant margin when it comes to graphics performance. So I know as a developer, it's probably very easy to just look at number of cores, but when it comes to real graphics performance, this is a quick fact chart for you guys. Now that you've known that Snapdragon and Adreno have better performance and architecture, or rather performance, let's look at some of the architectural facts. So the first fact is that Adreno GPUs have unified shader architecture. That means there are no fixed shader units assigned to process pixel and vertex operations separately. Vertex or triangle, however you want to say it. But in non-unified or fixed shader units, those are still common in mobile GPU architectures. We do see some mobile GPUs out there today that do still have non-unified shaders. Almost all of advanced consoles or desktop GPUs have adopted unified shader architecture. So we do, since we inherit some of the architectural facts from the Xenos GPU and Xbox 360, we made sure right from the word go, or the first GPU that we launched, we had these unified shader architecture. But what does it really mean to you, right? I mean, I know this is good to understand the architectural fact, but let's look at the diagram on the right side. So within the diagram, you have left side, which is represented by the Adreno GPU, while The right side is a competitor GPU, which is with the non-unified shader architecture. So you can see on the frame one, which is the leftmost column here, represents a triangle heavy scene, which basically could be any game that's out there. And you can see how the non-unified shader architecture is inefficient in processing because it limits how many triangles are processed at a time, and hence leaves out some of the wasted cycles which cannot be used to process additional triangles. The process that are wasted, I've represented those in the wasted cycle with the orange box. This is just a representation, just so you know. And then the frame X, on the other hand, which is the second column, and then the last column too, which is, on the other hand, could be a pixel-heavy scene, something like a UI, where similar inefficiency happens on the non-unified GPU, as you can see. But unified shader architecture, on the other hand, dynamically adjusts to the processing load, thereby processing both the scenes very efficiently, which means Adreno GPU delivers better performance for all scene types. And how you can really take advantage of that is another advantage of that unified shader architecture is you are able to fetch the textures even within the vertex shaders, which basically means you can use this additional texture data to manipulate your vertex coordinates. Here's a quick example. If you look at the source code that is embedded in the slide here of how you can read a texture in the vertex. You can use this trick to do something like a displacement maps for rendering water effects, for example. So anyway, I mean, this is just a quick example, but if you want to learn more about shader optimizations, I would recommend that you go to Adreno SDK and refer to the OpenGLES developer guide for Adreno that we have in there, and it has a full section on optimizing shaders. You can also refer to pre-optimized shader demo source that we have in the Adreno SDK, and it does include a lot of popular gaming effects shaders that we have in there, and those are all available free. In fact, I'll go in a little bit detail into those samples later on in this presentation. Next slide talks about Adreno GPU and support for early Z reject feature. So early Z reject basically prevents processing of pixels for occluded geometry. If you look at the diagram on the right side, you can see that the part of the blue box is occluded behind the orange object in the foreground. So the Adreno GPU is intelligent enough to not waste the processing cycles to process the hidden portion of the blue object in the background. The hidden portion is actually highlighted in the checkered pattern, if you can see that. So to take complete advantage of this feature, I think what we recommend is you need to order your draw calls of geometry in the scene from front to back. So if you look at the scene on the left, we have a scene that is depicted from the game called Oil Rush by Unigine. So you have a HUD element or menu, which is on the bottom right of that screen. Then you have oil wells that are in the foreground, or we call in the, I've called those out in the orange box over here. Then we have water. Then we can draw water, and then we can draw the oil wells in the background. Oil wells in the background, and then we can draw the skybox. So this is the order you should draw your objects in. So irrespective of the hardware architecture that lies underneath, it's always a good practice to order your geometry draw calls from front to back, which will ensure you best performance in any architecture. Another architectural feature of Adreno GPU is deferred rendering architecture, which basically batches the scene data into multiple batches called as bins, and then uses that bin data to render into an internal tile buffer, or what we also call as graphics memory or GMEM. You'll see that context clarified later on too. So the final rendered scene part from that tile buffer is then written out to the final frame buffer which lies into the system memory. So effectively what you're doing is you're rendering everything into the internal memory and then writing a single write to the external system memory. This saves significant memory bandwidth as there is effectively only one write to the system memory from the GPU. But again, I mean, this is a cool fact on the hardware side, but what does it mean to you? So you can use effects like transparency or anti-aliasing without affecting the performance. And that happens because as the GPU does not have to read or write back and forth between the system memory and GPU for these operations, but instead this all happens within the high bandwidth connection that is inside the GPU to the internal tile buffer. So that's the advantage of deferred rendering architecture. To take the best advantage of deferred rendering architecture, I think we recommend that you minimize the render target switches as much as possible. So the first thing is basically you avoid altogether the use of any off-screen or FBOs. But even if you need to, then you render completely to the FBO first before switching to the mainframe buffer, as shown in the flow diagram on the left side, or left bottom side, as you can see. So you render to the off-screen, and then you start rendering to the mainframe buffer. So the effective render switch is only once. You don't want to write to the main buffer, then write to the FBO, then again start writing to the mainframe buffer. That's just like two render switches, which is ineffective. Apart from the architectural features that we discussed, which were part of Adreno GPUs even earlier, there are some of the new architectural additions that we've made in Adreno 300 series GPUs, which would be very interesting to you guys. So let's look at some of those. The first one is flex render technology. So this is the feature of the Adreno 300 series GPUs, which allows it to dynamically switch between deferred rendering mode, which we just talked about, and the direct rendering mode, as shown on the right side. So if you look at the diagram on the right side, the top one is a direct rendering mode where your GPU is directly writing to the system memory, whereas deferred rendering mode is depicted on the bottom where it goes through an internal tile buffer. So this basically feature, what it does is it assumes the best performance for scenes with different loads. So let's say, for example, deferred rendering mode is going to be more effective in most of the gaming use cases, so we do recommend using that. But in some cases, let's say where you have a scene load is very minimal, or you're rendering to a single layer, so depth complexity is very low. Or one of the conditions that we've mentioned here in the slides, like you have a persistent surface update, or you have a mid-frame update, or you have a heavy usage of render to texture, it may be useful to switching to direct rendering mode. So in these cases, you can force Adreno GPUs to render into the direct rendering mode by using the suggested API call mentioned here on the slide. But as I said before, deferred rendering mode is better for most gaming use cases, so we recommend that. It might also be interesting for you to know that Adreno GPU drivers also have ability to dynamically switch between the most effective rendering mode at runtime. So if you don't know which mode you want to use, you can just let it alone, and the Adreno GPU driver will automatically detect it and do it for you. So it makes your job easier and chooses the most efficient way of rendering your scene. Another new architecture of worthy mentioning is double rate half precision design. So this feature allows for processing of half or medium or 16-bit precision, however you want to call it, those shaders at twice the rate. What this means is that it will leave you with more room to squeeze in even more additional effects, which could be longer or complex shaders. And that happens because the already existing shaders that you have are going to be processed in half the time than what they were supposed to on other architectures or even in the earlier generations of Adreno GPUs. So to make use of this feature, what we recommend is you use medium P as a precision specifier in your GLSL fragment or compute shaders. And if you need to use full precision for certain cases, then what we recommend is you use like a mixed precision, like we've shown here. So the example at the bottom of the slide basically has a compile flag or macro definition. You can decide at the compile time if you want to use high P for certain variants or not. So this feature is particularly useful for games, of course, when you're doing complex fragment shaders or effects, and you want to do process those fast and performance efficiently. And you can also use these for GPU or compute where performance is essential. So that was of the GPU, but we also design our own CPUs from ground up. A unique feature of Snapdragon CPUs is asynchronous symmetric multiprocessing architecture, or what we've also called as ASMP, which basically means that each CPU core can run effectively at different frequency, which is non-standard with the other ARM CPU cores. So let's say an unused CPU core can be completely turned down when it's not used. So in order to make use of multiple CPU cores on Snapdragon, we recommend that you use multiple threads within your application to take advantage of that. Also, another fact is that each Snapdragon CPU core comes with a SIMD functional unit, what we also call as Venom, which is instructionally compatible with the Neon processor that or SIMD unit that standard ARM cores come with. So we recommend that you make use of these SIMD units for any math-intensive calculations within your applications, just to ensure better performance for your applications. Okay, this is basically a flow diagram that shows the data flow for a game or a graphics application on an overall Snapdragon system on chip. So as you can see on the left bottom side, there are multiple CPU cores. In this particular case, I've represented 4 cores here, and this is only representation, so I've simplified it a bit for you guys. And then the CPU cores are processing individual functions from these game engine as they use multiple threads. And you can see some of the idle cycles that I've identified those by highlighted checker box, specifically on the second core and the fourth core. So in those kind of cases, Snapdragon CPU cores can turn those CPU frequencies down so that you don't intentionally run those CPUs at a higher frequency and waste battery or power consumption at that point. So CPU is effective in those kind of use cases. On the right side, you can see Adreno GPU, which includes unified shader architecture, which is efficient for shader processing, as I explained before. And there's also an internal tile buffer, which is mentioned here as a GMEM or graphics memory in here, which is used for a deferred rendering architecture or deferred rendering mode, so which saves additional data transfers between GPU and system memory, which system memory actually hosts the final frame buffer. So it does save a lot of memory bandwidth over there. So that's another optimization that is depicted here. Additionally, there is also an option to render into a direct mode, as I've shown here. And as for where all the data is hosted within the part of this SoC, you can look at the textures, vertices, and shaders and commands. Everything sits onto the system memory, which is on the top portion of the slide. And then the effective data that is transferred between the CPU to GPU is only basically command pointers. So you can see how efficient and the data is laid out when you're using your game laid on top of our processors. Okay, now that we have looked at the architecture and performance advantages of Snapdragon and Adreno, let's look at some of the middleware support that Snapdragon offers, which will make your game development easier. So here's the diagram that explains the data flow of the middleware solution. On top, you have your mobile application or game In the middle is the middleware engine or solution that sits between your application and the underlying hardware. And then hardware basically comprises of the operating system and driver. So I kind of made some assumptions over there. So this is how the data flow is mostly for mobile applications that use middleware. An interesting fact is we've seen that more than 80% of the traditional games today use some sort of middleware solution. The middleware solution could be in form of engine, a complete engine, or could be a sort of a simple library. Rendering, UI, video, AI, or artificial intelligence, audio, and networking. These are some of the examples of these middleware solutions. So what Qualcomm does is Qualcomm works with all popular middleware vendors to provide optimal user experience on Snapdragon. So what does that mean? I mean, what do we really do is we do some optimizations for particularly like general GPU optimizations and implementation of features like maybe like skinning or lighting or advanced lighting or new API support to the rendering engines. For physics and AI libraries, they tend to be more computationally heavy. So the optimal use of multiple cores and SIMD units is important. And then for video and audio libraries, it is important that they need to make use of hardware-optimized codecs and SIMD units. And then networking algorithm optimizations are essential for efficient use of 3G or 4G LTE data connection. So apart from these, we also look at some of the overall memory usage optimizations. So you can see at Qualcomm, we not just focus on the GPU or CPU optimizations, we are focused on overall optimizations for the whole processor, for whole system on chip, so which basically translates into a better performance. So if you're using any middleware solution, we try to make sure that you have a good experience out of the box. So these are some of the popular middleware solutions for gaming that are out there today. So we have some demos for you to showcase some of the games that use some of these middleware solutions. They'll be coming soon. But let's look at some of these before we go into the demo directly. So Unity Engine, you guys might know this is most popular engine on mobile today. Unreal Engine is also leading solution from PC and console space that has successfully made it onto a mobile. Crytek is another popular. They have a CryEngine, which is popular on the PC and console space. We also have Unigine, which is known for their high-end DX rendering technology and have successfully made it to mobile. So we'll be showing video demos of games that are running on Unity, Unreal, and Unigine middleware solutions right after this slide. The physics engines, Bullet Physics Engine is a popular open source 3D physics engine. We've made sure that it's optimized for Snapdragon, and if you go at the open source branch, you can see Snapdragon optimizations within there. Box 2D is another popular 2D physics engine, which is open source and is used in popular games today, like Angry Birds, for example. We have a demo of a game called Rigonauts that is based on Box 2D engine and uses some of the optimizations that I mentioned before. As for the audio libraries, there are popular libraries like FMOD and WWise, and SRS is another example. So we in fact did a lot of demos throughout this year within different trade shows where we showed SRS and 3D surround sound demos integrated within the gaming solutions and showcasing on Snapdragon S4 platforms. So with that kind of introduction, I guess there's also other rendering libraries that includes like Enlighten solution from Geomerix, which is an immersive dynamic lighting solution for mobile. And this solution is basically popular more on PC and console space, and now they're coming to mobile. So it's very useful for you guys if you're focusing on mobile. So by supporting all these popular middleware solutions for optimal use of the hardware, we ensure that these solutions are ready for you or use and basically make your job easier. So all these middleware solutions are available from their appropriate makers. So you can visit their websites for more information and even download and try those out. But let's look at some of the demos that we have here. So let me launch a video here. So the first demo here is a game from K-On Studios, which is called Team Dragon. It is based on Unity. But you can see the kind of effects that it has. It has a lot of shadows and particles and other rendering optimizations that were included in here. And a very popular game genre, fighting. So this is just an example of Unity. This is a demo of a game called The Ball, made by Tripwire Interactive, used with Unreal Engine. You can see all the high-end rendering effects, all the transparency on the ball. It actually goes into very open environments. We did optimizations to some of the culling algorithms and physics. It's a very physics-based game, so it does use SoC pretty hard. The next demo is the Oil Rush game based on Unigen's engine. And you can see advanced water rendering effect here. There's a lot of reflection, refraction, some of the displacement maps that are happening, large open rendering scenes. And this is a game that was on PC, and same thing with the other previous games too, and those actually got ported, and we optimized those for Snapdragon. So this is a quick example of what is possible with these middleware solutions. This is a game called Rigonauts by Engine. This uses Box 2D physics engine. So you can look at, this is very physics heavy, very fun game where you can build your own ship and, actually interact with the enemies and fight. And there's a lot of physics going on, you can see. So it requires a lot of advanced, like it makes use of SIMD functional units, as I said, the Venom. So you can see, I mean, all these kind of demos that are based on middleware solutions, they do already make use of the optimized portion of the Snapdragon. The last thing I wanted to mention was the tools that we have to offer you. So Qualcomm offers comprehensive development tools, early access to the hardware development kits for Snapdragon, basically which makes easier for you to develop for Snapdragon sooner, even before the commercial platforms are available. We do give access to robust software tools. We'll go in details of all these, but which basically makes your graphics development and optimization faster and easier. And the Adreno tools support major operating systems and latest graphics APIs, making it a commercial-ready solution. So these are not just the tools for you to play on the dev kits for that matter. These are actual work on the commercial devices, and you can try and play with those. So the next slide is actually kind of represents what we have in terms of tools. So on the left side, you can see the hardware development kits, which we make those available to give you an early access. And we also provide some excellent development tools and SDKs, which are on the right side. So the SDKs include Adreno SDK and Profiler for graphics development, which we'll discuss in detail in following slides. The other SDKs include like AllJoin, which is a peer-to-peer communication SDK that is platform agnostic, so with which you can communicate between two mobile devices at a time. Treppen is a power optimization tool which gives you insight into power consumption for your application and also lets you optimize for that particular case. Vuforia is a very popular augmented reality SDK, and it also has a Unity plugin. So if you're interested in working with augmented reality, I think that's the SDK to go for. Gimbal is a context awareness platform which helps you get timely, relevant, and personalized content within your application. So if you are even thinking about context awareness and how you integrate, maybe you want to check out the Gimbal page over on our website. FastCV is a computer vision library optimized for mobile. So if you have any applications that make use of camera and computer vision, you should go look at that too. Snapdragon SDK lastly, is an extension to Google's Android SDK, which basically allows you to take direct advantage of Snapdragon hardware for any, differentiated experience that you may want to have with your application. So it's available on Android, Google's Android SDK download page. All you have to do is just, check the Snapdragon SDK checkbox, and it downloads for you. Apart from where I mentioned, all these tools are available on developer.qualcomm.com, so you guys can go and download all these tools. All the software tools that I mentioned are available for free, so all you need to do is just go and download, and you're done. Okay, the two main tools for graphics application development are for Adreno GPUs are Adreno SDK and Adreno Profiler. So Adreno SDK, what it is basically a collection of utility like, emulator or sample libraries or documentation, whereas Adreno Profiler is a runtime performance analysis and debugging tool, which runs on commercial devices and commercial applications. So both these tools have extensive industry-wide adoption. A lot of developers already use it. If you are not already using it, we highly recommend you guys go and download those. And those are available for multiple operating systems and support multiple APIs. Let's go in detail and look at these tools. So this slide talks about Adreno SDK. So Adreno SDK, as I said, has an API emulation for most of the graphics APIs. It also has advanced samples, which includes like simple tutorials of how to draw a triangle all the way to, how do I write a advanced game. We also bundle top 50 advanced shader effects, and I've shown some on the right side of the slide. So you can look at, animal materials like fur or elephant skin, or even a general lighting like ambient lighting, diffuse lighting, specular, Blinn-Flong algorithms, all these kind of different lighting or human materials, like you are trying to write a shader for a skin or an eye, or other effects like, warping, distortion, or tune shaders, or even materials like cloth or wood or plastic. All these samples are available, and those are pre-optimized for mobile use cases on Adreno GPUs, so and are available for free. So we definitely recommend you guys take a look at those. Apart from all these samples that I talked about, we also have utilities and libraries for compressing like textures or geometry, and we also have an awesome texture tool, which we call as Adreno Texture Tool, which lets you compress the textures as well as visualize those. We'll go in detail and take a look at that in the next slide, actually. Apart from all these different tools, we also have detailed developer documentation for multiple APIs. So you may want to check that out as well. So as I mentioned before, the Adreno Texture Tool, here's a screenshot of Adreno Texture Tool. This tool basically allows you to compress texture into multiple different formats that are supported by Adreno GPUs, and then even lets you compare with the original image. So you can see the delta, if the quality is better or not. It's just better to visualize with the side-by-side comparison. And another cool thing that I like about this tool is you can create a batch process. So let's say instead of dragging and dropping, compressing one individual texture at a time, you can just create a batch process and include that within your tool chain, so you can compress all these textures at a single time when you're creating a package for your application. So it's an awesome tool. You should check it out. So here's something new that we just recently launched. So we released Adreno SDK with DirectX support as of last week. It was at the same time as the launch of Windows RT and Windows Phone 8 from Microsoft. So as part of this support, what we have is we have advanced samples that are shown here on the right side. We also have a texture converter tool, which basically helps you compress the textures into a DirectX texture compression format. And also we have a new developer guidelines document that is basically specifically for DirectX APIs. So let's look at some of the samples that are running, SDK samples that are running on the commercial Windows RT device that is powered by Snapdragon here. Okay, so this is the commercial Samsung device that is based on Snapdragon, and you can look at the tune shading or non-photorealistic rendering here. You can look at the samples of the particle effects. There's also, environment mapping or other advanced lighting demos that we have within the SDK. We also have this particular one, I think, is depth of field effect. So these are very simple samples, but I think the idea of those is you can refer to these samples and integrate within your applications. So those are ready to be plugged in. This is a simple skinning animation, how you can use skinning on DirectX. This one in particular is basically a sky dome. If you're trying to write a sky dome, you can refer to this code. This is a very simple tutorial of how you can do a textured quad or a geometry, and then this is advanced lighting effects. So, with interest of time, I was not able to show you all the stuff that we have, but we do have enough samples, so I would recommend that you go and download the SDK and check it out. So another important tool for graphics development that we have to offer is Adreno Profiler. So here is the screenshot of that tool, Tools UI. As you can see, there are different modes within the profiler. On the left side, you're looking at the scrubber mode, and which is basically a one frame analysis, single frame analysis. And then on the right side, you're looking at a grapher mode, which is a dynamic or runtime analysis. So scrubber mode, you can get a detailed call stack of applications, as you can look at in the top bottom left side of the screen. And you can walk through them, all these call stack, and the tool actually will redraw the scene for you in the emulation environment as shown in the top left. You can also see and look at all the textures and shader data that was captured for that particular frame, and you can look at all the walk through all these textures, look at all the different MIP levels, as well as even edit shaders on the fly and send those back to the device in real time to see what the effect is. Something that would probably take you hours to, go back, change the shader, put it onto a device, or compile a new application, put it onto a device, and then see if it affects the performance. It's just very much efficient if you're able to edit it right then and there, push onto the device. So it's a very powerful tool. And on the grapher mode, where you can see is it's more for a dynamic performance analysis. So it has a comprehensive list of more than 100 registers that are exposed to gather all sorts of data that you need for your application. So the matrix column that you see on the right side is basically all the registers that are available. And Profiler also supports an override mode, which basically allows you to emulate some performance and optimizations and see, how that really affect the performance in real time. So let's say, for example, you want to see if the compressed texture, compressing the texture is really going to affect the performance or not. All you have to do is, simulate the smaller texture override, or with a click of a button, you are able to do that and see if it affects the performance. Otherwise, which would, mean that if you did not have a tool like this, you would have to go back, compress all the texture, then compile all your application, repackage it, put it onto a device, and then see if it affects the performance, which could be hours or even matter of days, depending on how big your application is. So with this tool, you can quickly find and fix performance bottleneck of your application. And then tools also supports another mode, which is a shader analyzer mode. So let's look at that. So as you can see on the screen, shader analyzer mode is where you can get detailed stats on your shaders and optimize them in real time. So on the left side, you can see the vertex shader code. On the right side, there is a fragment shader code. And at the bottom, you see all the statistics of the shaders, like how many cycles they're using. And the data is actually based on the data that is captured from the mobile device runtime. So you're not just looking at an offline compiler and generating some random numbers, but this is actually what the performance will be on the device that you're profiling on. You can also analyze and edit and modify those shaders on the fly. And on the right side, you see a column where it says available shader programs. So those are all the shader programs that are available in your applications that you're profiling. So you can not just focus on single shader, but you can even select any shader that is part of the application and start and analyzing it and even overriding it. So as you can see, Profiler is a very valuable tool, very useful tool for any application developer. And the good thing about this is it works on commercial devices with commercial graphics applications. So in other words, you need no change to your code or to the commercial device in order to use this tool. So how awesome is that? I mean, I wish if I had this tool when I was a developer, but it's pretty cool. So with that, I think, we should go to the Profiler demo. And I'll just walk you through some of the features of the tool that I talked about, but in real time. So here you're seeing a desktop where the Profiler tool is running, and on the background you see a game that is running on the commercial device. And what I've done is I've captured a scene from it, and I'm running in a scrubber mode. I'm going through the call stack. You can see how it's recreating the whole scene using the emulation. So I can totally see if there's any rendering calls that are repeated or something that I shouldn't be doing. I can even highlight a particular draw call and look at the shaders or programs or stats. I can visualize the scene in different modes. I can, let's say, wireframe mode, for example, over here, or I can look at the depth complexity that happens. So it does have different visualization modes. I can look at the textures. So right now I'm going through the texture stack and I'm clicking on the textures. I can look at multiple MIP levels and the MIP, that are available for those textures. And even, in fact, I can highlight and see which MIP level is getting used. This particular one, I actually modified the shader code to turn it into a pink, and I send it over to a device, and you can see the actual chord turns pink. So I can actually modify those shaders and send it onto a device on the fly, and I just reverted it back. And now this is a grapher mode, and you can see I can plot graphs of multiple things, whatever registers I want to gather data on, while the game is running onto the device. So game is actually in a pause because I'm not playing it, but it's still running, it's rendering. So that's why you see all that. Okay, so you see, I mean, this is pretty awesome tool. So in conclusion, I guess now that we've covered all the points and looked at all the things that we have to offer, I think we can confidently conclude that Snapdragon and Adreno provide a leading platform for graphics application development. And that is mainly due to the market opportunity that Snapdragon provides, as well as the performance and architectural advantage that Snapdragon and Adreno have. The second thing is Snapdragon makes it easier to develop great applications, and that is because of the excellent optimal support for middleware solutions on Snapdragon and Adreno, and also the great Adreno tools that we have to offer you. So with that said, I think, we would really like to convey to you guys that we're eager to work with you guys. To get your hands on any of the tools that we mentioned today for free, go to developer.qualcomm.com and download these tools. And we also recommend that you sign up for a Snapdragon Developer Program for opportunity to work together on your next big graphics application or game that you have. With that, I think I've covered all the slides that I wanted to, and I want to thank for your time. And at this time, I guess we can take any questions that you may have.
Thanks, Manish. Now we'll open it up for questions. Again, if you'd like to submit a question to us, you can do so by clicking the red Q&A icon at the bottom of your screen, or you could tweet the question to the hashtag SnapdragonGraphics. So we have a couple questions that came in. So the first one, Manish, is what's the difference between the Snapdragon SDK and the Adreno SDK?
Oh, yeah, that's a good question. So Snapdragon SDK, as I said, is more like an extension to the Android SDK that is available from Google. So you can imagine that when you're downloading the Android SDK from Google website, there is a checkbox which will allow you to download the Snapdragon portion of that SDK as well. It does have, some features like if you want to do like particular camera features that Snapdragon provides, or even graphics features for that matter, all those are bundled into as an extension for Android SDK. Whereas Adreno SDK is more graphics development focused, so you can use, it does have samples and utilities and documentation more for graphics development, more so for like OpenGLES and, DirectX or all sorts of those graphics APIs.
All right, thank you for that. The next question is, what kind of developer opportunities are there in the GPU area?
Yeah, I mean, that's a good question too. But we didn't touch so much on the GPU or compute side, but we'll soon be coming out with OpenCL support. We haven't announced when, but it will soon be out. And then we also will provide with the corresponding tools for those. I guess when the developer platforms and tools are available, that would be probably the right time to talk about GPU and what the opportunities are for that. But as of now, I think I would just like to say that, yes, it's coming soon. Okay,
thanks. The next question is, do I need a Snapdragon CPU to run the SDK?
No. So the way SDK is, and I guess you're talking about Snapdragon, Adreno SDK when you meant by SDK. So no, I mean, Adreno SDK is basically a desktop side of emulation and all that. So all you need is a desktop PC and you can emulate and use that SDK. As for the samples, those are optimized for Adreno GPU, but that does not mean that they cannot run on other GPUs. So you're free to use those on other GPUs and other processors as well. We just do not guarantee the performance of those on others.
So does that mean the SDK could be run on the laptop?
Yes.
The next question is, how can Qualcomm help me get my games or applications in front of OEM customers featured on the website or preloaded on Snapdragon devices?
Yeah, so I mean, we talked about Snapdragon and its market reach, and you can see us as, working with every OEM that's on the planet and every carrier out there shipping the Snapdragon device. So we do have that pathway to, I guess limelight, or however you want to say that. But in order to get opportunity through that, what we recommend is you sign up for Snapdragon Developer Program and then submit your application ideas or applications with a little more details, and we'll come back to you. We do fund in some cases where the application that showcase our technology best, and we even help them market and get the preload opportunities through our sales and marketing channels. So that is definitely a huge opportunity, and I definitely recommend you guys to take advantage of that by signing up to developer program.
Okay, thanks. The next question is, when will your tools fully support Windows RT? And in what cases do I use tools from Microsoft, and in what cases do I use Adreno tools?
Okay. So, I think for Windows RT or Windows development, DirectX development, Microsoft does have very good tools, very comprehensive list of tools. What we offer as part of Adreno SDK is an additional, or we can call it as a complementary samples that are optimized and take advantage of Adreno and Snapdragon overall. So we do have Adreno SDK, which includes all these samples today. The Adreno Profiler is something that is coming out soon, basically with the similar functionality of what you saw in Profiler, but you would be able to profile your applications on DirectX on Windows RT platform or Windows Phone 8 platform. So what does it really mean is Microsoft tools allow you to profile at the API level, whereas on Adreno Profiler, you would be able to profile your application more at a system level and at the hardware level, so you can override the drivers, yes, and also look at the some of the like CPU use cases and optimize for GPU and look at the vertex data, texture data, and optimize for those. So I think our tools are more hardware focused and more vertically, whereas Microsoft tools you can look at as more horizontally at the API level. So those do go as complementary to each other. So as I said, Adreno SDK is available today. Adreno Profiler will be coming out soon.
All right, thank you, Manish. And we don't have any more questions in our queue right now, so if you have any, please submit them. We'll wait another minute or so to see if any more come in, and then if not, we'll go ahead and wrap up the webinar. Also, note that if you have any follow-up questions after the webinar, you can always go to our forum. So the Mobile Gaming and Graphics Optimization Forum is on the QDevNet, the Qualcomm Developer Network website, and that is developer.qualcomm.com/forum. And if you want to post any questions there, we'll respond to those questions in a timely manner.
Cool. Thank you, Katie.
All right. Well, we haven't gotten any more questions in, so we'll go ahead and conclude today's webinar. So again, we'll email you the slides and the recording of this webinar by next week. Thank you, Manish, and thank you, everyone, for joining us today. And I hope you have a great afternoon.
Thank you. Bye.